Alrighty, in this video, we are going to be talking about logarithmic integration and what that is. So far, we have talked about using u sub and using your basic integration rules to take the antiderivative. Today, I'm going to include two new tricks and tips on integration techniques. The first one, we are going to be using long division, and then the second one, we are going to manipulate u in terms of what we have so far. But here, let's say that for number 10, we let u be x plus 5. Then du is going to be 1 dx. Obviously here, if I were to take this and I substitute n into dx right here, I'm not going to cancel out x cubed minus 6x minus 20 anytime soon. Likewise, if I were to do the same thing with the x cubed minus 6x minus 20, I won't be able to get x plus 5 to be canceled out. So unfortunately, I can't use u substitution here. But like I said at the very beginning of the video, we are going to be using long division or synthetic division, whatever you prefer. Here, I am going to be using synthetic division because I'm dividing by a linear factor, x plus 5. At this point, you should be able to divide using synthetic division since this is a math 3 topic, so I'm not going to explain how I got this. By now, you should know how to do this. Once I do that, I get the quotient of x squared minus 5x plus 19 minus 115 over x plus 5. And remember, that is just the quotient of this thing right here, my integral. So we haven't done any antiderivatives just yet. So the only thing that I did was just simplify this so that we can make it nicer and so that we can integrate this easily. Because now I could take the integral of x squared, because that's just 1/3 x cubed. I could integrate 5x, that's just going to be 5 over 2x squared. I can integrate 19, and then to integrate 115 over x plus 5, that's just me using u substitution again. Or if you already know this, because this is a coefficient of 1, it's going to turn into 115 ln of the absolute value of x plus 5. And then don't forget about your constant of integration. So this is going to be your original function. All right, so for number 11, the first thing that we want to do is check if we could use u substitution. And if we can, then that's great, because then it's going to be a little bit easier for us to work with. Whenever you have a fraction right here, always choose your u to be your denominator. Most of the time, it is going to be the denominator. Whenever you choose u as your denominator. I get u to be x cubed plus 3x squared minus 4, which means that du is going to be 3x squared plus 6x dx. And I'm going to make this a little bit prettier because right now, I want to relate that so that it looks like x and x plus 2 so that it cancels out. So here, I'm going to get 3x and then x plus 2 dx, which is good for me because I have an x and I have an x plus 2 and I have an x and an x plus 2. And remember that these will cancel out whenever I take the reciprocal of this, and it's going to be in my denominator. Once I do that, I'm going to get 1/3, and then the integral of 1 over u du. The integral of 1 over u is going to be ln of the absolute value of u plus c. And then we know that u is x cubed plus 3x squared minus 4 plus c. This is my antiderivative of number 11. Right, I'm going to skip 13 for a bit, but let's move on to, not 13, 12. I'm going to move on to 13. This one right here Yes, I did say to choose u to be the denominator, and most of the time it will work. However, if I do that, I am left with a product that I have to derive for this one right here. So I'm not going to choose u to be x ln x, just because then I'm going to have product. And if I just choose x right here, the derivative of x is just going to be 1, which doesn't really take care of my ln of x. However, if I do u to be ln of x, then du is going to be 1 over x dx. And if I take the reciprocal of this is going to be x, and it's eventually going to cancel out to this right here, meaning that I'm going to be left with the integral of 1 over u du. Take the antiderivative, so you have the ln of the absolute value of u, and then since u is ln of x, I have ln of the absolute value of ln of x plus c. All right, so for number 15, I want you to pause the video, and I want you guys to actually do 15 on your own. It's very similar to 14, and then I'm going to quickly do the subs for this so that we can move on to something like 13 and 16. Now, for this one right here, once you simplify 1 over x cubed times 3x squared, you're going to get 3 over x dx, which is going to be perfect because then if I take the reciprocal of this, the x's will cancel out, and I'm just left with a 3 times whatever my integrand is, in this case 1 over u du. Integrate that, plus c. So then I have 3 times ln of x cubed plus c. Ooh, beautiful. All right. Number 15 is a definite integral from 0 to 1, and I have x minus 1 over x plus 1. This one right here, I can't really use u substitution because then I'm going to get to x plus 1. Du is going to be 1. Can't really do that. So, once again, I'm going to use synthetic. If you want to use long division, fine. I don't care. If it works for you, then it works for you. So then my quotient is just going to be 1 minus 2 over x plus 1. And remember that we're still taking the integral from 0 to 1. Okay? So then if I take the integral or the antiderivative here, I'm going to get x minus 2 ln of the absolute value of x plus 1. And this is from 0 to 1. So then if I were to do that, I'm going to evaluate my upper limit, then evaluate my lower limit of 0. Notice how here ln of 1 is going to be 0, so then you have 0 minus 0 is just 0. So then you're just left with 1 minus 2 ln of 2. Now, if this was a multiple choice question, remember that you have properties of logs that you use. So if you see something like this where you have 1 minus ln of 4, don't be surprised. Because right here, I could use this and bring it up as a power using my log rules to get 1 minus ln of 4. Right. For number 12 here, I have x times x minus 2 over x minus 1 to the third power. I can't really use division right here because I have to actually multiply this out and multiply this out. And then even if I still do that, since my denominator has a higher exponent, a higher degree, you really can't really divide this in terms of what I have right now. So let's go ahead and just try and use u substitution, where u is x minus 1. And then du is going to be 1 dx. This is very similar to number 15. And what we're going to do here, which we'll also redo 15 again in another video. Here, we're going to have the integral of x minus 2, and then u to the third power du. The problem with this is that I still have an x right here and I have an x right here, which is no bueno because I want this in terms of u. However, I could do that using a little trick. So one of the integration tricks that we could do is just solve for x in terms of u. So here, if I set u to be x minus 1, then I can also have x to be u plus 1. And if that's the case, then I could take the integral of u plus 1 times u plus 1 minus 2 over u to the third power du. So then I have u plus 1 and then u minus 1, which will eventually become u squared minus 1 over u to the third power du. I am going to go ahead and use the quotient property of exponents and have 1 over u minus 1 over u to the third du. And then at this point, just take the antiderivative of 1 over u and take the antiderivative of 1 over u cubed. And that's going to give us the absolute value of ln of u. And then that's going to give us, let's see. This is going to be u to the negative 3, so we're going to up our power. So that's going to be u to the negative 2. And then we're going to have 1/2 plus c. And because u is x minus 1, I'm going to have my final answer to be ln of the absolute value of x minus 1 plus 1/2 x minus 1 to the negative 2 plus c. Now, you can make it a little bit prettier so that you don't have a negative exponent. That is fine. And this is going to be your answer for number 12. Using our trick of substituting in x to be u plus 1. In another video, we'll talk about how we could do that in number 15 and still get the same answer. Okay, 16. For number 16, this question is not asking you to find the derivative. So even though I have a function right here, you might think to do FTC part 2, but don't do that. You're just going to take the antiderivative of 1 over t, which is ln of the absolute value of t. And then we're going to have our bounds of x squared and 1. So that means that I'm left with ln of x squared minus ln of 1. And we know that ln 1 is 0. So your answer here is just ln of the absolute value of x squared. Now remember that I do not need a plus c or a constant of integration because this is a definite integral here. So I'm going from 1 to x squared, so I really don't need a plus c in my answer. Now, for number 17, we haven't really talked about area, and this we will talk about in terms of unit 6, so the next unit. But for now, this is just going to be a little introduction of what area is going to be. So here it tells us we want to find the area bounded by the region of x is equal to 1, x is equal to 4, y is equal to 0, and then y is equal to x plus 4 over x. I don't know what x plus 4 over x looks like. The only thing I do know is that it's going to be bounded by, let's say, if I have a coordinate plane, 1, 4, and then a y is equal to 0. So your thing might look something crazy like this, where this is x plus 4 over x. Now, as a reminder, this isn't explicitly x plus 4 over x. This is just a made-up graph. But I want you guys to visually see what's happening, because remember, area is just the integral of whatever we are going from. So in this case, this is going to be the integral from 1 to 4. And then my integrand is going to be whatever I have, in this case, x plus 4 over x, which I am going to clean it up a little bit to get 1 plus 4 over x dx. All right, I am going to take the antiderivative of that. So that's just going to be x plus 4 ln of the absolute value of x from 1 to 4. So now we're just going to evaluate that and see what that gives us. So that's going to give me 4 plus 4 ln of 4. I'm going to drop the absolute value sign just because 4 is already positive right here. And then I have 1. So now I have 1 plus ln, well, 4 ln of 1. And we know that ln of 1 is 0, so that just goes away. Which means I'm left with 4 plus 4 ln of 4 minus 1, or 3 plus 4 ln of 4. Once again, if you don't see this answer, it's probably because the 4 got raised as a power. So if you see 3 plus ln of 256, then that's why. I'll let you guys do 18. To find the average value, remember that's just going to be 1 over b minus a. Then the integral of 0 to 2 of secant pi x over 6. And then the x. So your final answer should look like this. Now, with number 18, though, we haven't really talked about the integral of secant. So that's going to be one of the integrals that you might need to remember using the sheet that I gave you guys at the very beginning of Unit 4, where it listed out all of the antiderivatives. Secant should be one of them, so use that antiderivative to help you with number 18. You should get 3 over pi times ln of 2 plus root 3. Now, will you get this on a test? Probably not. It might be something like cosine or sine, but not something like secant. All right. So in the third video, I am going to talk about number 15, not using synthetic, but using our little trick right here that we learned on number 12. So that's going to be the next video.